In this lecture, we're going to look at the facilities from the C++ standard library to play with C strings. All of these are going to be living in the C string library. You can go and check it out at CPP reference. And we're going to start and look at a few examples of some of the things we can do with this library. I mean C string. The first thing we're going to look at is an example of how we can check the length of a string. Here we have a character array called message1. It is a character array, and you see that we made it const. We also have another array that is pointed to by a pointer. You know that if we do things like this array is going to decay into a pointer, and there are a few things we can do with it. For example, we can't use it with std size, and we can't use a range-based for loop to loop through this message2 thing here. But strlen is going to help us check the length of this thing here. So we can use it. For example, if we do std strlen message1, we're going to get the number of characters in this string here. This is not going to count the null character though. So the null character that is implicitly added in by the compiler is not going to be counted in here. You're going to see this in a minute when we hit Visual Studio Code to play with these things. But this facility can work regardless of whether you are using a row array like this or even for pointers like this, and it is really cool. So we can use it like this. We're going to get it printed out. Please note that we can also use the size of operator to get the same thing. So it is going to work almost the same way, but the size of operator is going to include the null character. You need to be aware of this. The good thing about strlen here is that it still works for decayed arrays. So if we use it on message2, we're going to get the correct output. We're going to get the number of characters in here, which is really cool. And we can also try and print out the size of message2, but here we're going to get the size of a pointer printed out. Okay, that's how strlen works. It lets you evaluate the length of a string. Here is another example, and it is strcmp or string compare. It is used to compare strings. What you're going to do with this facility is give it two strings, C strings, we should be exact. And one is this guy here, LHACE or left hand string. I think that's what this stands for. And we're going to give it a right hand string. And by the way, these signatures are copied straight from the documentation so that we can look at this in one slide to make it really easy to follow. This is going to return a negative value if the first guy happens to come before the second guy in lexicographical order. So it is something like A comes in front of B, C comes in front of D, or something like that. If the two strings are equal, it is going to return 0, and it's going to return a positive value if the first guy appears after the second guy. Okay, and we're going to try it out. We have two strings, Alabama and Blabama here, and they are stored in character arrays that are pointed to by these two pointers, string data1 and string data2. And we can do something like this below here. So we're going to print something out, and we're going to say std string compare, and we're going to pass in the first string and the second string. For now, I want you to pause a little bit and try to guess what we're going to get printed out here. The first string is Alabama, the second one is Blabama, so the first one comes in front of the second, and we see that we're going to get a negative value if the first guy comes in front of the second guy. So Alabama comes in front of Blabama, and we would expect to get something negative from this thing we are doing here. And again, if we try and change them up a little bit, you see that Alabama still comes before Alabama. So we're going to get a negative value pointed out, and we can change these things up to see what we get. It is really simple if you know how to use them. We can also use another version of string compare, which is going to let us specify the number of characters that we want to compare. We can specify that we want to compare n characters. In this case, it is 3 characters. And it is going to compare a section of the strings that you specify as a first and second parameter here. So for example, if we change string data1 to be AAAIA and string data2 to be AAANCA, and we are comparing 3 characters in here, so we are comparing AAA to AAA, we're going to see that they are equal, and we're going to get a 0 printed out here. You're going to see that this is exactly the case when we get to play with us in Visual Studio Code in a minute. We have a facility that we can use to search in a string and search for a character. The facility for that is strchr, and it is going to find the first occurrence of a character in a string. And the documentation for this is right here. And please note that this example is actually copied straight from the documentation. Okay, so we have a message here. It is a character array and it is pointed to by a const char pointer called str. And we have a target character that we are looking for. And the result is going to be stored in the result character array here. And we have a variable called iterations that is going to keep track of how many iterations we did to find our target here. The way this guy works, it is going to return a pointer to what you find. If it is found, for example, in here, if we find this first t, this function here, or this facility is going to return a pointer to this first t here. If it doesn't find what we want, it is going to return a null pointer. That's how it works, and you can see that in the documentation here. We are going to take advantage of how it works in this while loop here, and the way you use this facility, you give it the string you want to search in, and you give it the character that you are looking for. So if we look at how it works in the while loop here, we are going to call the function and we are going to store the result in our character pointer here. And if we go inside, we're going to hit the first character here at the first iteration. So we're going to find this t here. And when we find it, the result of this is going to be stored back in result here. I hope this makes sense. So we're going to find it, we're going to print it, and we're going to increment result to make it point to the next character. This is pointer arithmetic in action here. And after we do that, we're going to increment the iterations. So we should have one iteration by now. And we're going to jump into the loop again. So the string we search in is going to be starting from R here. So we're going to try and find an uppercase Tn, and it is going to find this uppercase T here. So it is going to point to it, and the pointer to this T is going to be stored in this result here. Okay, and we're going to jump into our body here. We're going to say that we found this T, we're going to print it out, and we're going to increment result. If we increment result, now result is going to be pointing to the H here. Okay, and we're going to say how many iterations we did to find our thing. We will have printed out the T that we have found, and we're going to jump to the next iteration, which is going to be searching for T in the remainder of the string here. It's not going to find it, of course. It's going to return null pointer, and the test here is going to fail. And we're going to fall down here and say how many iterations we found. I realize this example can be really confusing. I am going to try and explain it again when we hit Visual Studio Code. For now, know that this facility can help you find characters in a string. That's the message here. There is also another function that helps you find the last occurrence of a character in a string. For example, here we have a character input. It is a path to a file on some Linux system or Mac system. And we have an output character pointer, which is going to store the pointer to the character that we found. Okay, if we find the character, we're going to store in the pointer to that character. If we don't find it, we're going to return null pointer. I think that's how this thing works. So what we really want here is to hunt for the file name in this path here. And this is really interesting. So we're going to search for the backslash, the last one in this string here. And it is going to find this guy here because that's the last occurrence of a backslash in our input string here. Once we find it, we're going to get a pointer to this guy stored in the output character pointer here, and we're going to print it out. What we're going to do, we're going to use pointer arithmetic to move this pointer to the next guy because that's what we really want. We want to print starting from the H here, and that's what we're going to get when we print this out. Now that we have looked at all these examples, I think it is time we headed to Visual Studio Code and actually played with them. Okay, here we are in our working folder. The current project is C-string manipulation. That's what we're going to work on. We're going to copy our template files and we're going to put that in place. And we're going to open this in Visual Studio Code pretty quick. Let's include C-string because that's what we're going to be using. Many of the things we're going to be playing with in this lecture are documented in this piece of documentation here, so you can come here and get more details than we could even cover in a course like this. Let's bring this up a little bit, and we're going to go in our main function and put in the first piece of code we can play with. The strlen facility is going to find the length of the string, and it's going to work regardless of whether you are using a row array like this, or even if you are using a character pointer to point to your array. And this is pretty cool. So here we have strlen message1. We're going to print that out. We're going to print how many characters we have in this guy here. We're going to also use the size of operator to try and compare these things. But please note that the null character is going to be included if you use size of here on a row array. This is very important to know. But one interesting thing about strlen is that it is also going to work if you are storing your array in something that is pointed to by a pointer. So even decayed pointers are going to be usable here, and this is pretty cool. So we can also try and print the size of message2, which is pointed to by a row pointer, and we're going to see what we get. But we know that we're going to get the size of a pointer because that's what it really is. Message2 here is just a pointer. Okay, let's close this on the left, and we are going to bring up our terminal and try and build this with GCC. We're going to do that. So we're going to use GCC to build this. The build is going to go through, and we're going to clear and run Rooster again. And this is going to give us what we want. strlen message1 is 16. Size of message1 is 17 because size of is also going to count the null character. strlen message2, you see that it works even if we have a decayed array that is pointed to by a pointer. And this is really useful. If you happen to need the size of an array like this, you can use strlen and you're going to get the size of data in there. But note that the null terminating character is not counted if you use strlen here. And size of message2 is going to be 8 because that's the size of a pointer on our system here. So note that this guy is just a pointer. Okay, that's the message here. We are going to comment this out. The next thing we're going to look at is strcmp, which can be used to compare strings. So it works exactly like we said. It's going to return something negative if the first string happens to come in front of the second string in lexicographical order. For example, here we have a few variables. We have Alabama and Blabama. They are strings pointed to by pointers, so they are C strings. And we have a couple of other strings stored in row arrays like this. And by doing this, I want to prove that this facility is going to work regardless of how your array or your C string is stored. So we're going to use that here for our C string pointed to by pointers. We're going to try and compare whatever is in string data 1 with string data 2. String data 1 has Alabama, string data 2 has Blabama. So if we compare these guys, we expect to get a negative value out of this thing here, strcmp, because Alabama comes in front of Blabama in our alphabet. So A is in front of B, so we're going to get a negative value out of this. And we expect to get the same thing in the second example here, which is going to be using what we store in our row array. So make sure you understand this, and we're going to try and build this to see that it passes through our GCC compiler. The build is good, so we're going to clear and run Rooster, and you're going to see that we get a -1. I want you to play with these things and try and change, for example, the A to a C and see what you get. Okay, we're going to try and build, but before we do, try to expect to see what you get. C comes after Blabama. So if we look at this description here, we should get a positive value because the first guy comes after the second guy in lexicographical order. So we should get a positive value for the first thing that we print here. Okay, let's build and see if that's the case. We're going to build successfully. We're going to clear and run rooster. And you see that the first guy prints a 1 because Klagama comes before Blabama. And the second one is going to still be a -1 because we still have whatever we had before in there. Okay, this is how you work with these things. Let's turn this back to Alabama so that we are not confused. And we're going to keep working on this. In the next piece of code, we are going to try and modify whatever is stored in string data 1 and string data 2 and print the comparisons out. For example, we have Alabama and Alabama. And by the way, we are able to modify that because it is a pointer to a string. And notice that this is not a const pointer, so we can really change where this guy is pointing, and that's what we are doing here. But we can't do that with string data 3 and string data 4 because these are arrays, and remember, you can't change where an array points. So this is going to compile nice, but if we try and do the same thing with string data 3 and string data 4, let's do that. You're going to get a compiler error. So we're going to put this guy here and say 3 and 4. And we should see Visual Studio Code complaining here because this is not allowed. You're not allowed to make an array point to another location. And this is just another character array or const character array in memory that we want these pointers to point to or this array to point to. And this is not possible. So we're going to get a compiler error if we do this. This is something I wanted you to know. That's why I set up this example here. So if we run this, we're going to see the first line of output here. Or I think I should comment that out. Or let's not comment it out. Now, if we run this program, we're going to get the output for Alabama and Alabama printed out. And Alabama comes after Alabama, so we expect to get a -1 because the first guy here comes in front of the second guy. So we're going to get a -1 out of the thing we are doing here. Let's try and build with GCC. The build is going to be good. So we're going to clear and run rooster. And we're going to see that we have a -1 here. Alabama comes in front of Alabama. So this is cool. So we can try and put in many other examples for you to play with. I am going to do that because I don't want to type all these things. And we're going to print the result out. For example, we put in India and France. We put in Kigali and Kigali, and we're going to get things printed out here. So let's build this so that we don't waste time. We're going to clear, and we're going to run rooster, and we're going to see that we get these things here. Alabama comes after Alabama, so we get a 1. India comes after France, we get a 1. Kigali comes together with Kigali, and we get a 0. You can try and put in whatever you want. These are just a few examples for you to play with. And by now, I hope you really understand how this function works or this facility works. So we're going to comment it out, whatever we did here. So we're going to comment all this out so that we don't have noise output in whatever we want to do next. And what we want to look at next is this function here, which is going to compare strings in the same ways, but we're going to tell it to compare however many characters in the string. And you see that my string here has been commented out. I can quickly take it and bring it down here. Let's do that. I can't find that. Let's find that and copy it down. And we're going to find them here. So I'm going to find this and bring that down here so that I can compare these things. So let's come down here and print and put in our declarations for these strings. And you see that Visual Studio Code is happy now. So what we're going to do is compare a set of characters in these strings here. Okay, so we're going to compare any characters in our strings. So we're going to compare Allah to blah here. And Allah is going to come in front of blah. So we're going to have a -1 printed out here. But if we change the strings to AAA and AAA here and compare the first 3 characters, we're going to get a 0 printed out because the first 3 characters are equal. And again, the special thing about this function is that it allows you to specify a number of characters you want compared in these 2 strings. So you can say, I want to compare 3 strings. You can say, I want to compare 4 strings or 5. Just make sure that you don't go over the size of the string. And if you do that, it's not going to make sense what you are trying to do here. If we go down here, we're going to change n to 5, and we're going to be comparing all these things in here, and we're going to get that the first one comes in front of the second one because I comes in front of n in our alphabet. If we change the data to O here and n, O is going to come after n, and we're going to get a positive number printed out here. We're going to try and run this. So let's run the task to build with GCC. The build is going to be good, and we're going to clear and run Rooster. And we're going to see that Alabama comes in front of Blabama because we are comparing the first three characters. If we have AAA in here and we compare the three characters, you're going to see that they are equal. We get a 0. If we change I and N here, we're going to get a -1 because I comes in front of N. If we use O here and N, we're going to get a 1 because O comes after N. This is really simple to understand. Now that we know how to use the first version of string compare, this version is just going to allow us to specify how many characters in the string we want compared. So we're going to comment this out, and we are going to go down and do another example that allows us to search for a character in a string. And the method we use to do that is std strchr. So this guy is going to find whatever target you want to find, and if it finds that, it's going to return you a pointer to that target. If it doesn't find it, it's going to return you null pointer. So we set up an array here, and we store that in a location that is pointed to by the pointer to character here. And we say whatever target we are looking for. In this case, we want to find this T here. We are going to set up another character array that is going to store our result. The result is really going to be a pointer, which is going to be pointing to something valid if we find the target. And it's going to be null pointer if we didn't find the target. And we set up another variable which is going to store how many iterations we did. We should really make this an unsigned integer or size t, so let's make that here. And we're going to loop here. So the first time we loop in here, we're going to call this guy. We're going to say, I want to find a t in result here. And the result is going to be pointing to this thing here because we did the assignment here. So it's going to go in and try to find a t. It's going to find the guy here at the first index. And the test here is going to succeed. When it succeeds, it's not going to be equal to null pointer. It's going to be pointing to a valid pointer. And it's going to succeed and return the pointer to be stored in result. After this guy returns, the pointer is going to be stored in the result here. And that's going to be a pointer to this t. And we're going to jump in the body here. I really want you to understand how this thing is going to work. Once we get in the body, we're going to say, we found our target. That's going to be our t printed out. And it's going to start at this location. Okay, and we're going to print starting from the t here because that's what our result here is pointing to. After we do that, we're going to increment the result to make it point to the next character. If we do that with pointer arithmetic, now we're going to be pointing to the r in here. I hope this makes sense. And we're going to increment our iterations. So we're going to say we have done one iteration, and we're going to try and run this again. And by the time we get in here, we're going to have this string here in which we are searching for a t. And a t is going to be found starting at this second t here, the there here. And it's going to find it. It's going to store the pointer to it to result here. Or I should say, the search is going to be successful. So we're going to find the pointer to this t and return it from this function here. And the pointer is going to be stored in our result pointer here. We're going to jump in the body and we're going to print, we found the target starting at this t. We're going to print that out. And stdcout is going to print until it meets a null character. So we're going to print this thing through the end. And we're going to put a /n, which is going to move us to the next line. After we do that, we're going to increment result. And result now is going to point to the h here. And we're going to increment iterations. Now we're going to have done 2 iterations by now. And we're going to run the loop again. This time the loop is going to fail because starting from here, we don't have a t. And this function is going to return null pointer. And this test here is going to fail. Okay, we are going to return null pointer. null pointer is not going to be different from null pointer, so this is going to fail. And we're going to fall down here and say how many iterations we're going to find. So in total, we're going to do 2 iterations, and we are going to find 2 t's, and we're going to print whatever we find here. Make sure you really understand this. And I put in this example on purpose because it is a little complicated, but it is going to really bring your game up in how you use these functions from the C++ standard library. And you really need to know this. If you have any problem with this, be sure to ask me. I will do the best I can to help you out. So we're going to build this and run this. We're going to build with GCC as always, and we are going to clear and run Rooster. And you're going to see that we are looking for T. We are going to say we found T starting at the T here. So we're going to say tried. Okay, we're going to print all the message out. And the second iteration is going to find T starting at this location here. And we're going to do 2 iterations in total. We're going to comment this out. And again, if you don't understand this, please go through it again. And if you still don't understand, be sure to ask me. I am going to do the best I can to help you out. And some of you might be asking, why did we go through the trouble to store this guy in result? Why don't we use str in the first place in here? And the explanation I can come up with is that you don't really want to modify this guy here, because somebody is going to look at this thing and say, this is the message I have in str here. But if you try and modify this in the loop, it's going to be messed up because you're going to be incrementing it and doing all kinds of crazy things on it. So you don't really want to modify this. So a better way to even do this is to mark this as a const pointer. And we know how to do that. So we can say const here. And if you even try to increment str somewhere, you're going to get a compiler error. So let's make sure we see that. For example, we try and do ++str. We're going to get a compiler error because this is a const pointer by now, and this is much safer. Okay, we're going to comment this out and show you something that might throw off many of you guys. So we're going to comment this out, and I am going to bring that in. Okay, let's go down here, and we are going to do basically the same thing, but we will try and use str in the first place here. Okay, this is how we're going to do this. We're going to have our string, we're going to have our target, we're going to have our result here, which is equal to null pointer, and we have our iterations, which is an integer. Let's make this a size t. And what we're going to do in here, we're going to use str to search. Okay, and we're going to basically do the same checks. We're going to jump in here and say we found target starting at result, and we're going to increment str here because it is not a const pointer. Now, try to go through this thing here and see how many times you're going to loop. Okay, go through it, and when you are done, we're going to try and run this. We're going to build with GCC. The build is going to be good. We are going to clear and run Rooster, and you see that this guy is going to loop 25 times. And this is crazy. Why is this happening? Why is this happening? What we really are doing here, we are not assigning the result in the string that we are searching at. Okay, let's try and go through this a couple of times. So the first time we're going to do our search. Okay, so we're going to search in str, and if we find our target, we're going to return the pointer to the target. If we don't find it, we're going to return a null pointer. The first time we're going to find this t here. Okay, and we're going to return a pointer to it and store that in result. Okay, so after we do this, we're going to fall in our body here, and we're going to say we found t starting at this location here. That's going to work. And we're going to increment str. Okay, notice that we're not incrementing result here. If we increment str, it's going to point to the next character, which is r here. Okay, and we're going to increment our iterations, and we're going to start a loop again. We're going to search in here, and we're going to be searching from this location here. And we're going to find a t starting at this location. We are going to find this t here, and we're going to return that and store that in result. But the problem is that what we are incrementing here, is that we are incrementing one by one. We are not jumping to this t here. And we had a way to jump to this t by assigning the result into the same variable that we are searching in. Okay, so this is going to loop 25 times and it is not really good. And some of you might try to set up something like this and it is really not going to be good. Try to go through this and you're going to see the reason why it is looping 25 times. Okay, I wanted you to see this. Don't do something like this, and we are going to comment this out. The next thing we're going to see is how we can find the last occurrence of the character. And this is a really cool example. I like it. It is going to do something very practical. We are going to take a path, which is going to be an array basically stored in this input array. And we're going to strip off all the things we don't need, and we're going to hunt down for the file name from a full path. And this can be useful in whatever application you are doing. So we are going to hunt for the last occurrence of a backslash character using the strchr facility in the C++ standard library. And you can find the documentation on this guy here. I'm not going to go there. You should really practice to go there and read what these things do. That's why I am leaving in the links to the documentation. You should go there and read. And if you have a problem, you can ask me. I will do the best I can to help you out. So this line here is going to hunt for the last backslash. It's going to find this guy here, and we're going to store a pointer to that in our output character pointer here. After we do that, we're going to say if we found something useful, if this is not null pointer, we're going to print that out. But we don't want to print starting from the backslash. We are going to use pointer arithmetic and move to the next character, which is going to be this H here. So if we print this out, we're going to have hello CPP printed out, because stdc out is going to print until it meets the last null character, and that's going to be after the last P here, because this is a C string literal here. Okay, we're going to build this. The build is going to be good. We're going to clear and run Rooster, and you're going to see that we have hello CPP printed out here. Okay, this is really all we set out to do in this lecture. I apologize that it turned out to be lengthy. These things can take long to explain, and I really wanted you guys to have as many explanations as I could come up with. We are going to stop here in this lecture. In the next one, we're going to see how we can copy and concatenate C strings using the facilities from C string here. Go ahead and finish up here and meet me there.